Hi, this video I'm going to tell about the segmentation. What is meant by segmentation? So it is one of the memory management scheme that supports the user view of memory. So normally we know that what is meant by program. So program means it is a collection of segments. So segment means the example for segment is it is a logical unit. So it may be a main program, it may be a procedure, or it may be a function. It may be a method, it may be an object, it may be a global or local variables, common block, stack, symbol table, and arrays. So this is actually the user's view of the program, as already mentioned in the previous video. So the logical address means the CPU generated address is called logical address. So logical address here, it is divided into number of segments. So in this example, there are 5 segments listed. One is subroutine, second one is a stack, third one is a symbol table, and fourth one is a SQRT function, and fifth one is a main program. So this is a logical view of segmentation. So this is actually logical memory, and this is a physical memory. So logical memory, so we have how many segments are there is in this example. I have 4 segments, so namely 1 2 3 4, and this is stored in physical memory in not a contiguous order. It is a non-contiguous order. That is segment number 1 is stored initially, followed by segment number 4, then we have some free space, followed by segment number 2, and followed by segment number 3. And what is meant by segmentation? Actually, the segments, actually the CPU generated address, it is called logical address. So it will be divided into 2 parts. So one is a segment number. First one, it is a segment number, and the second one for to offset. So these are the 2 tuples of a logical address. One is a segment number and other one is a offset. So by referring the segment table, it maps into 2-dimensional physical address. So for that we use the segment table. So the purpose of the segment table is to map 2-dimensional physical address. So here the segment table contains 2 parts. One is a base register, and another one is a limit register. So what is meant by base means it contains a starting physical address where the segments reside in memory. So that is a base address, and the limit address, it specifies the length of the segment. So for that we are using segment table. And another register, that is a segment table base register, SDBR. It points to the segment table's location in the memory. And one more register, segment table length register. So it indicates the number of segments used by the program. For example, here the segment length is 4. That is segment table length register. Here it indicates number of segments used in the program. So it is 4 actually here. And here we use the production also. So each entry in the segment table associate a validation bit. So if it is a validation bit is 0, means it is an illegal segment, and read or write or execute privileges. So the production bit is associated with every segment actually. So segmentation example is shown in the following diagram. So this is a diagram. So as I told initially, so CPU generated address is called as a logical address. So logical address is divided into 2 parts. What are the 2 parts we use it here is, one is a segment number. This is actually the segment number, and this is a offset. So offset means D. S denotes for segment number, and D denotes for offset. By referring the segment number, it will go to the segment table. So as I mentioned in the previous slide, segment table contains 2 parts. One is a base address, and another one is a limit address. So by referring the segment number, it will go to the particular base address of that particular segment, and what is the length of that particular segment, that is a limit. So by referring that, it will go and store it in the physical memory. So I will show one example. So here, as I mentioned in previous diagram, I have 5 segments. Segment 0, it is a subroutine. Segment 1 is a SQRT function. Segment 2 is a main function. Segment 3 is a stack, and segment 4 is a symbol table. So this is a segment table. Segment table contains 2 registers, 2 address. One is a base address, another one is a limit address. So for segment 0, what is a base is 1400. So here actually it is a 1400 here. Wait. So this is actually 1400. segment number 0, and the limit is limit for segment 0 is 1000. So 1400 to 2400 segment 0 is stored in the physical memory. So segment 0's base address is 1400 and limit is 1000. So base and limit will be added. So 1400 plus 1000, it will be segment 0. And the segment 1 base address is 6300. So 6300 is the base register for segment number 1. Segment number 1 is here 6300. So here it is 6300, and what is the limit of that segment number 1 is 400. So 6300 to 6700 segment 1 is stored. Similarly, segment 2 base address is 4300. So 4300 it is segment 2, and 4300 to 4700, that is limit is 400. So 4300 to 4700 is segment 2 is stored. And segment 3, the base address is 3200. So 3200 to 4300 segment 3 is stored. Similarly, segment 4 base address is 4700 and length is 5000. So 4700 to 5700 segment number 4 is stored. That is an example for the segmentation. Thank you.